Section 1.2. We talk about algebraic limits, their properties, and then we use those to talk about what we call continuity of a function. So we start by letting or given the limit of f of x as x approaches a, say it's L, and the limit of another function g of x as x approaches a is m, and let c be the constant. Then we have the following properties. The limit as x approaches a of the sum or difference is the sum of the limits or the difference of the limits. So the limit of the sum is the sum of the limits. Limit of the difference is the difference of the limits. And in this case, if this is L plus or minus M. Limit of the product is going to be the product of the limits. And this equals L times M. Limit as x approaches a of a constant times a function. You can take the constant out. Limit of the function as x approaches a. Limit of the quotient is the quotient of the limits. Provided that the limit of the denominator is not 0. So this would be L over M. This would be C times L. We have more properties for limits. If we do limit as x approaches a of f of x to the mth power, you can move the limit inside. Limit as x approaches a of the nth root of f of x, you can also move the limit inside. We can continue the first one by it's L all to the small m, or L to the m. This is the nth root of L. Find the limit as x approaches 2 of x squared minus 5x plus 8. So the way it works is the limit of this is the limit of the first one minus the limit of the second one plus the limit of the last one. Here by the properties, you can move the limit inside, limit of x as x, the square as x approaches 2. You can move the 5 outside as x approaches 2, and this stays the same for now. Now it's ready for us to move or to do the limit. So it's kind of like you substitute the 2 in times 2 and the 8 stays the same. This is 4 minus 10 plus 8. So that gives us 2. So all these steps must be shown to get points for or to get the credit. The same thing, let's look at another example. X goes to 7 of the square root of x squared plus 5x plus 3. The way this works is you move the limit inside, and then we do the same thing. Limit of the first one, limit of the second one as x approaches 7, limit of the third one as x approaches 7. And then we pass the limit inside, take the 5 out, and do the calculations. You get 7 squared, 5 times 7 plus 3, and that gives me the square root of 87. Another example. Here h goes to 0, not x goes to 0. So the way this goes, again, limit of the first one plus limit of the second one plus limit of the third one. As h goes to 0, h goes to 0. That means the other variable is just a constant. So this is just a constant, 3x squared. You take the x out times 0 plus 0 squared. So the answer is 3x squared. Sometimes we try to find the limit of an expression such as this one as x approaches 2. And what happens here is you do this equals limit of the top and then we notice if you pass this, you're going to get 2 squared minus 4, 2 minus 2. So that gives 0 over 0. That's called indeterminate form. We cannot determine the value of this. So we need to find a trick around this. What do we do in this case? One way to do the trick is to do factoring. Let me recall a factoring formula. It says difference of squares, a squared minus b squared. That's a minus b times a plus b. That's what I do on the top, x minus 2, x plus 2. Keep the denominator the same. These cancel out. Then when you pass the limit, you're going to get 2 plus 2, which is 4. That gets rid of the 0 over 0 form. We can look at another example. Limit of x squared plus 4x minus 12 over x squared minus 4 as x approaches 2. So how do we do that? Limit as x approaches 2. We can factor, if you pass the limit, you're going to get 0 over 0 again. We can factor the top one and factor the bottom one. X minus 2, x plus 2. So on the top you get x plus 6, x minus 2. These cancel out. So what does that give us? 2 plus 6 over 2 plus 2. 8 over 4, which is 2. Next one. Limit of 4 minus x squared of x minus 2 as x approaches 4. Again, this will go to 0 over 0. What can we do next? Well, we can factor here, let's say. What can be another trick? Another trick is to rationalize the denominator. Rationalize, what does that mean? We multiply by what we call the conjugate. Same denominator, switch the middle sign. On the top you get 4 minus x squared of x plus 2. In the denominator you do the first one square minus 2 square. This stays the same. Stays the same. X minus 4. Notice these cancel each other with a negative sign. They are opposite of each other. So now we need to find or calculate the limit of this expression by substituting, kind of like passing the limit inside. That will give us negative 2 minus 2, negative 4. That's about limits, how you find limits. The other part is continuity. What is a continuous function? Continuous, something like this. You don't lift the pen up or pencil up off your paper. There's no holes, jumps, nothing. That's a continuous function. What can be examples of not continuous? I'll show 3 examples. On the XY plane, one example can be like this. This is not continuous. We call it discontinuous. Because there's a hole there. Or something like this. That's also discontinuous. Or something like this. There's a jump. All these graphs are discontinuous. Now, how to prove a function is continuous? We say a function is continuous at a point x equals a if the limit of f(x) as x approaches a from the right side is the same as the limit when x approaches a from the left side equals f of a. So the function is continuous at every single point in its domain. Then it's called continuous. So in order for a function to be continuous at one point, like at a point A, this condition must be met, but this condition must be met. So let's say we have function f of x, 3x minus 5 if x less than 2, or 2x plus 1 if x bigger than or equal to. Is f of x continuous? Is f of x continuous or not? To do so, we know this is a straight line, it's always continuous, and this is another straight line, it's also continuous. What happens is at this point here, at the condition, do these two lines get connected? That's called piecewise function. Are they connected at that point or not? That's what we're going to check. So to do so, we just have to check, basically, is f of x continuous at x equals 2? Well, to do so, we need to find the limit of the function as x approaches 2 from the right side. We need to find the limit of the function as x approaches 2 from the left side. From the right side, is the 2x plus 1, which gives us 2 times 2 plus 1, that's 5. Next one is 3x minus 5. Again, 3 times 2 minus 5. If you pass the limit with its properties, it's 1. Notice they're not the same. They're not the same. So we say since the limit of f(x) as x approaches 2 from the right side does not equal the limit of f of x as x approaches 2 from the left side, this means f is not continuous at x equals 2 and hence not continuous. Again, in order for a function to be continuous, it has to be continuous at every single point in its domain. At every single point at its domain. Since it's not continuous at 2, then it's not continuous. One other example, let's say we have this piecewise function x squared minus 9 over x minus 3 if x is not 3, 7 if x equals 3. Is f continuous at 3? Means that x equals 3. We have to find the limit. So if we try to find the limit as x approaches 3 from the right side of f of x, limit as x approaches 3 from the right side. So this is saying if x is exactly 3, use this. If it's not 3, like above 3, below 3, use this. So 3 plus is a little bit above 3. We can do it this way. This will go to 0 over 0. Then what we can do, factor the top, x minus 3, x plus 3 divided by x minus 3. These cancel out, and passing the limit, that gives us 6. 3 minus is going to be the same thing. How about at f of 3? Because 3 conditions need to be met. 3, we find 3 of them, they all have to be equal. From the right side, left side, and at the point itself. f of 3, when x is 3, it's 7. So they're not the same. If it happened that I changed this to 6, then it becomes continuous. But it's not. They're not the same. So the limit of f of x as x approaches 3 from the right side does not equal f of 3. So we say f is discontinuous at x equals 3.